name is William and I'm from Chocochatty Elementary, and I have decided to do my science challenge on static electricity. So you walk across the rug, you reach for the doorknob, and zap, you get an electrical shock. Want to know why and how? The answer is static electricity. Static electricity is an unequal amount of positive and negative charges in or on the surface of an object. So, atoms are all around us. Everything around us is made up of atoms. Atoms are the smallest parts of an object. So small they can only be seen with a microscope. So, there are three parts of an atom: a neutron, proton, and electron. The neutron is neutral, and the proton is positive, and the electrons are negative. The charges stay there until they are able to be moved by an electrical current, charge, or discharge. Are usually neutral because they have the same amount of positive and negative charges. When two objects touch together, electrons may move from one object to the other. On one object, the positive and negative charges stay there. So, right here I have a Van de Graaff generator, and it was invented by American physicist Robert J. Van de Graaff in 1929. This 200,000 volt generator can produce all kinds of static electricity, and even a spark you can see. So, right now I'm going to show some demonstrations, and this one I just have some tissue paper taped onto the dome of the Van de Graaff, and what it's going to do is that when I turn it on, all the tissue paper is going to stick up. That's because they have the same charge and they repel each other. As you can see, it sticks up, but when I put my hand, it absorbs all the charges and it goes onto my hand. But when I put the wand over it, it does the same thing. So I close. This demonstration is very similar to the tissue paper. I have a metallic wig and I put it over the dome of the generator. What it's going to do is it's going to stick up like the tissue paper. That's because they have the same charges and they will repel. As the same, when I put my wand over it, it goes down because it absorbs all the charges. Okay, so right now I have some mini pythons that I put over the dome. So when I turn it on, the pythons are going to fly everywhere and make a big mess, obviously. So when I turn it on, in this demonstration, I will turn on the Van de Graaff generator, and I have a light bulb here, and when I touch it or put it close to it, it should light up rapidly, but not fully, because the sparks jump to the light bulb, which contains a current that's strong enough to actually light up the light bulb. Make sure you hold it far away from the metal as possible, or else you're going to get shocked. As you can see, it is lighting up very rapidly, not fully. And now, my favorite trick of all. See, right here is a discharge wand, and when I place it close enough to the Van de Graaff generator, it discharges the positive charges from the dome, which causes a spark. Now, prepare for some lightning. You can see, it causes a big spark. So, this part of the Van de Graaff generator is called the bell, and it's positively charged. And right beneath there, I don't know if you can see it, but it's a lower roller, and that's negatively charged. So when you put the object on the Van de Graaff generator dome, it really depends on the object, and that will cause the reaction. So what we learned today is that this is a Van de Graaff generator, and it produces static electricity. It creates mostly positive charges, which a lot of my objects are positive, so it will repel. And why my school should be celebrating and leading science is because that our school is crazy about science. We even have a special guest every year called Professor Marshmallow, who does all kinds of cool demonstrations. And if we had the $10,000 for a lab, it would be absolutely amazing. We have lab equipment already. It's very run down and it doesn't work very well, but it still works, and and having the $10,000 for our lab would be life-changing.